In this video, let's solve question 4. In this question, we have the following diagram shows part of the graph of y equal to x over x squared plus 2 for x greater than or equal to 0. The shaded region R is bounded by the curve, the x-axis, and the line x equal to c. The area of this region is ln3, and then we want to find the value of c. Okay, let's first call the area A and the function whose graph is given in the diagram f. Okay, so let A be the area and f of x be x over x squared plus 2. Then from calculus, we know that the A is just the integral from 0 to c of f of x dx, which is equal to the integral from 0 to c of x over x squared plus 2 dx. If you take a closer look at this integrand, you will see that it consists of two parts. One part is the x squared plus 2 in the denominator, and the other part is a multiple of its derivative in the numerator, which is x. So this tells us that we can calculate this integral by substitution, with the substitution being in u equal to x squared plus 2. Okay, so let's first write down some calculation on the right. So here we make the change of variable u equal to x squared plus 2, then its derivative du dx will be 2x. This implies that du is going to be 2x dx. So 1/2 du is equal to x dx. Next, we want to find the range for the new variable u so that we can update our limits in the integral. Okay. First, we know that x is greater than or equal to 0 and less than or equal to c from the original limits of the integral. So 0 is less than or equal to x, which is less than or equal to c. Because u is equal to x squared plus 2, we want to make some transformation such that x squared plus 2 pops up in the inequality. So first we square the whole inequality, which gives us 0 is less than or equal to x squared, and also which is less than or equal to c squared. Okay, this implication holds because now x is greater than or equal to 0. So if we have an inequality for non-negative numbers, then we will have the same inequality for their squares. Okay, and then we add 2 to this inequality, which tells us 2 is less than or equal to x squared plus 2, which is less than or equal to c squared plus 2. Alright, so now we have x squared plus 2 in the middle of this inequality, and this is our new variable u. So this way we get the new range for the new variable u. So now we can continue calculating this integral. So it is equal to the integral of. So now we make the change of variable first and then update the limits, because this way we can avoid ourselves from forgetting updating the upper and lower limit. So here the denominator x squared plus 2 is just u. So we have 1 over u, and then x dx is equal to 1/2 du. So the integral becomes 1 over u times 1/2 du. And then we take care of our new limits. So the lower limit should be 2, and the upper limit should be c squared plus 2. Okay. So this integral is easy. It is 1/2 ln u with limits c squared plus 2 and 0. Okay, so we get 1/2 times ln u c squared plus 2 minus, the lower limit here should be 2, so minus ln 2, which can be further simplified into 1/2 times ln c squared plus 2 over 2. Okay. And from our assumption, we know that A is equal to ln 3. So this implies that 1/2 ln c squared plus 2 over 2 is equal to ln 3. And then we take by the logarithm rule, we can take the constant 1/2 inside the natural log, so we get ln of c squared plus 2 over 2 to the 1/2 is equal to ln 3. So this means that c squared plus 2 over 2 to the 1/2 is equal to 3, because we can take the exponential on both sides, and then the exponential cancels with the natural log. Okay. So, and then we square the both sides of this equality to get c squared plus 2 over 2 is equal to 9. So c squared plus 2 is equal to 18. Hence, c squared is 16. So c is positive or negative 4. However, from the diagram above, we see that c must be positive. So there is only one choice, that is c is equal to 4. So this is the answer for question 4.